The first thing we need to understand about integrating trig functions is that most of the time you do not use the power rule for trigs. Now we will eventually get into the deeper trig functions just like we did with derivatives where you do have to take into account the power rule. But for the basic trig functions, you don't need the power rule. So what you need to do is you need to make sure that you know what the 6 basic derivatives are. What are they? The derivative of sine is
Cosine.
Therefore, the integral of cosine will be sine. The derivative of cosine is
Negative sine.
so the integral of negative sine must be
Cosine.
they go forwards and backwards. The derivative of tangent is
Tangent squared, secant squared.
just
Tangent, secant squared.
okay, the derivative of tangent is just secant squared. So the integral of secant squared should be just tangent. Make sense, you guys? Okay, so let's try this. So forget the power rule, just look up here and we want to try to figure out whose derivative is sine of x. So we know it's related, that sine and cosine are related. So if this is sine, the answer is going to have something to do with cosine. Now if I put just cosine of x plus c, and I try to take the derivative, I'm off by a negative sign. So what you do is you just balance it out if you need to, and you put a negative on the answer. If that had been the integral of negative sine, it would just be positive cosine. So you just have to make sure that the answer you give differentiates back to the original. So let's look at the integral of cosine. We know that cosine is related to sine. So we think that's going to equal sine of x plus a constant. And do I need a negative here or not? No. Let me just look at it. The derivative of sine is positive cosine, and we already have that, so we are good. If we want to find the indefinite integral of secant squared of x, we know that secant squared of x is the derivative of whom? Tangent of x. So the integral of secant squared has to equal, what does it have to equal? Tangent of x plus c. And we can always check these by just looking at the final answer and making sure that its derivative was the original problem. Cosecant squared is part of the derivative of whom? But cosecant squared is part of the derivative of cotangent. Do y'all understand that? That cotangent and cosecant squared are related. So if I just say cotangent of x, I'm going to be off by a negative. So I need to just fix that by putting a negative here so that when I do take the derivative, it will be positive. So don't worry about the negatives until the end. Then just kind of look at it and see. I mean, you know that, the c's a lot of times need a negative. We just don't know, where to put it until we take a moment to consider it. All right, whose derivative is secant tangent? Secant. And we'll keep our variable the same. So that will just be secant of x plus the dreaded unknown constant. And finally, if I would like to take the antiderivative of cosecant of x, cotangent of x with respect to x, should it be cosecant of x or should it be negative cosecant? Yeah, we are going to have to balance that one. So we have negative cosecant of x plus c. And if we look at that, it does differentiate to this guy. So now let's talk about what happens if there's a coefficient in front of one of the 6 basic trig derivatives. All you do is you basically just keep the coefficient. So we know that to integrate cosine, that would integrate to sine, right? Right? But we have a negative 3, so we want to include the negative 3. The cosine will become a sine, and I think that will work out, right? Because with a trig function, to take its derivative, you just keep the coefficient and take the derivative of the trig function. So that's all we need. And then finally, let's talk about this one. We have the integral of 3 sine x with respect to x. What's the final answer? Where's the negative come from? Yeah. I needed my derivative to be positive 3 sine x, but the derivative of cosine is negative sine. So, but if I put a negative here, this negative and this negative will undo each other and bring me back to sine. And that's all you need to know about trig integrals for now.